Hello everyone, hope all of you are doing great. And in today's video, we're going to discuss Paper 1, Unit 8, but this is Part 2. Part 1, which is from question 1 until question 25, is also uploaded to Google Classroom. All right, starting here from question 26, Yuri tries to convert some fractions to their simplest forms. Tick to show if his answers are correct or incorrect. Here I'm going to divide this. He divided this by 8 and divided this by 8 as well to get 2 over 6. But this is incorrect because it's not the simplest form. Not the simplest form. He needed to divide here by 2. Divide here by 2 is going to give you 1 over 3. The other one over here is dividing by 7 is dividing by 14 is 1. Now here dividing by 14 is it going to give you a 7? Well, definitely no, mister, because 56 divided by 8 is a 7, so it is also incorrect. Or if you would like to simplify it yourself, you can just say I'm going to divide by 7 is going to become 2, divide by 7 is going to become 8. Then divide by 2 and divide by 2 is going to become 1 over 4. Mister, it's not 1 over 7. Here, 17 over 6 to 8. If you divide this by 17, it's going to give you a 1. But if you divide 6 to 8 by 17, is it going to give you a 4? There is one way to find out. Will 4 times 17 and 1 times 17, will they give you the same? 1 times 17 is giving me 17. Yes. 4 times 17, let's do it. 4 times 7 is 28. Get rid of the 2. 4 times 1 is 4, and 2 is going to give you a 6. So 68. Yes, mister. 17 divided by 17 is 1. 68 divided by 17 is 4. This is the only one that is correct. Let me erase all the working out over here. Just because I'm going to save this for you later. I can leave this. All right, next question says to you, work out 6 and 1/4 divided by 1 and 2/3. Keep change flip hemisphere after you convert this into an improper fraction. So 4 times 6 is 24, plus 1 is 25 over 4. Divided by turns into multiplied by. 3 times 1 is 3, plus 2 is 5. So it is a Mr. 5 over 3. But after the multiplication, we flip, so it would be 3 over 5. Simplify, then multiply. Don't multiply before simplifying. Here I can simplify this numerator with that denominator over there. So dividing this by 5 gives me here 5. Dividing this by 5 gives me 1. So it is 15 over 4. Mister, they want it as a mixed number. So the denominators stay the same. How many 4s are in 15? 3, remainder 3. So the answer is 3 3/4. Draw a ring around the fraction that is the largest. Here I've got 7 over 10, 19 over 30. Mister, I see that I can make all the denominators 30 because I cannot compare as long as the denominators are different. We can't. This is not possible. So this stays 19 over 30 as it is. This becomes 21 over 30. This becomes 22 over 30. This becomes 20 over 30. Now to rearrange this, they want you to start drawing around the fraction that is the largest. I'm sorry, that's not ordering, that's the largest. The largest one of them all is 22 over 30, which is 11 over 15. Write down the value of 7/3 times 5 times 3 over 7. Mister, you told us before that in multiplication we can simplify any numerator with any denominator. Only in multiplication, right? Yes, yeah, mister, we remember this. So can I simplify the 7 with the 7? Yes, 7 divided by 7 is 1. 7 divided by 7 is 1. And can I also simplify the 3 with the 3? Yes. Divided by 3 is 1 and 1. So all what I've got left is what? Just a 5. calculate 9 over 10 divided by 2 and 2 fifths. So it is going to become 9 over 10 times 5 times 2 is 10 and 2 it becomes 12 over 5. But after the multiplication sign, we're going to flip it. It is 5 over 12. Simplify, then multiply. Divided by 5 is 1. Divided by 5 is 2. Divided by 3 is 3. Divided by 3 is 4. So it's going to become 3 over 8. Here, we agreed before, if you're dividing, or usually actually, if the number that you're dividing by is greater than 1 in division, and multiplication, if it is greater than 1. Mister, we know that in division, if it's greater than 1, usually what happens normally is that it gets smaller. Answer gets smaller. And in multiplication, if it's greater than 1, in multiplying by greater than 1, answer gets bigger. But Mister, if I'm dividing by less than 1, the opposite happens. Answer gets bigger. If I'm multiplying by smaller than 1, answer gets smaller. But let's do it. Here, they divided. Mister, we said usually in division, answer gets smaller if it's greater than 1. Yes, that's why here the answer of this is going to become less than 20. Now here, Mister, I'm multiplying. Mister, usually in multiplication, an answer gets bigger. But 1 second, that's usually, yes, unless you're multiplying by smaller than 1. 3/4, that's smaller than 1. 1 is 4 over 4, right? That's smaller than 1. Good. So what? What is going to happen over here? Mister, you're multiplying by smaller than 1. No, multiplication is not going to be greater anymore. It is going to get smaller. So the answer is going to be smaller than 20. Here I'm multiplying by bigger than 1. Multiplying bigger than 1, answer is bigger. As normal. Dividing. Dividing a mister usually or normally, the answer gets smaller. Yes, that's right. Unless you're dividing by smaller than 1, answer gets bigger. Let's continue. 1 minus, I need to get that common denominator in here. So this becomes 8 as it is. This multiplied by 4 becomes 4 over 8. So it is 1 minus 5 over 8. Mister, 1 is actually 8 over 8. So as if you're saying to me 8 over 8 minus 5 over 8, it's the rest, 3 over 8. Or 1 whole, you took from it 5/8, then I have 3/8 left. Tick to show each fraction that is equivalent to a recurring decimal. Each fraction that is equivalent to a recurring decimal. Mister, we learned the test. We learned how to test this, how to test if this fraction is equivalent to recurring decimal or not. I check the denominator first, mister. I check first if it's in the simplest form or not. Simplest form, mister. But what about this? No, not simplest form, mister. Simplest form is 3 over 4. Simplest form, not simplest form, mister. It is 1 over 3. Now I tested the denominator. Does it have only 2 or 5 as prime factors? لا يا مستر 6 and 1 فيها 3. Then it is recurring. Tick, they said tick to show each fraction that is equivalent to a recurring. So this is recurring. 6 or 3 over 4. Mister, the denominator is 4. It has prime factors only 2. It doesn't have anything else. So if it had anything apart from, other than 2 and 5, كانت هتبقى terminating. But no يا مستر, كانت هتبقى, I'm sorry, كانت هتبقى recurring. But no يا مستر, it doesn't have anything other than 2 and 5. It has prime factors only 2. then it is terminating. Don't put a tick. Next one, 1 over 3. يا مستر لا دي ما فيهاش ولا 2 ولا 5. It has something other than 2 and 5. The prime factors of the denominator has something other than 2 and 5. Then, يا مستر, it is recurring. So take the first, take the last, don't put anything in front of the second. They're saying to you that n is an integer, where n is greater than 0, less than 15. N over 15 is equivalent to a terminating decimal. Draw a ring around the number of possible values of n. Mister, ده بيقول لي number of possible values. How many possible values are there? Right, let me tell you something. Here, they said to you it is equivalent to a terminating decimal. 15 itself cannot be equivalent or cannot be there in a fraction that is in the simplest form. Simplest form. 15? No way. ليه يا مستر؟ لأن here 15 has a prime factor other than 2 and 5. So 15 cannot be there. You must get something that simplifies 15. So, mister, you mean, for example, 3 over 15? Yes. 3 over 15 is going to simplify it to become 1 over 5, which is terminating. Right? طب هو less than 3, I started actually in my mind with 1 over 15. لا يا مستر, it will not be simplified. 2 over 15 will not be simplified, mister. 3 over 15, yes, it will be simplified. What else is there? I got also 4 over 15. لا, no, يا mister, no way. 5 over 15. Will it be simplified? Yes, it will be simplified to 1 over 3, which is still recurring. It is recurring, mister. I cannot take it. All right, what else? I got also, mister, in there 10 over 15. It will be simplified to what? Dividing by 5 is going to become 2 over 3, mister. No, mister. It still will be recurring. I cannot take it. We want only terminating. Is there anything else that will help us simplify the 15? Yes, mister, there's something that you forgot before the 10. It is 9 over 15. Right? Yes, I can simplify it. Divided by 3 becomes what? Becomes, divided by 3 is 3, divided by 3 becomes 5. Oh, mister, this is terminating. I can take it, and I can take this. Anything else, mister, that we forgot? Yes, I got also 6 over 15. If you simplify it, divided by 3 will give you 2 over 5, which is terminating. I'm going to take it, mister, as well. Anything else? Yes, we've got also 12 over 15. If you simplify it, it is going to become what? It is going to become here, mister, divided by 3 is going to become 4, divided by 3 is going to become 5, which is terminating, mister. How many terminating do we have so far? Anything else, mister, that will help us simplify the 15? No. You're going to find here, as we agreed, that 3 simplifies with the 15. 4, no. 5, yes. Simplifies, but it will still be recurring. 6 will simplify it, and it will be terminating. 7, no, it will not simplify with the 15. 8 will not simplify with the 15. 9, yes, it will simplify with the 15, and it will help us get a terminating fraction or a terminating decimal. 10, yes, mister, 10 over 15 will simplify, but it will be recurring, so we're not going to take it. 11, no. 12, yes, it will simplify to 4 over 5, which is terminating. 13, no. 14, no. So I've got how many fractions? I've got 1, 2, 3, 4. 4 possible values that will help us reach a terminating decimal. Next, question 33. Work out 8 over 9 plus 1 over 1 over 3 divided by 4 and 4 over 5. n is an integer where n is greater than 0 and less than 15. N over 15 is equivalent to a terminating decimal. Draw a ring around the number of possible values of n. All right, let's see right now. Here, I need, Mr. If I leave 15 as it is, it will be definitely recurring because it has prime factors other than 2 and 5. So it will definitely be recurring, Mr. So what are we supposed to do here? We're supposed to look for numbers for n between 0 and 15 that will simplify the 15 and will give me a terminating decimal. So let's try. 1 over 15. No, I missed 1 will not simplify the 15. 2 over 15. No, I missed the 2 will not simplify the 15. 3 over 15. Yes, I missed 3. 3 over 15 will simplify to 1 over 5, right? Which will be terminating. Thank you. So I'm going to take it. What are other options there? 4 over 15, no, I missed it. It will not simplify with the 15. 5 over 15, yes, it will simplify. To what? To 1 over 3. Aha, but this semester will be recurring. I cannot take it. What else semester is there? 6 over 15. Yes, I can simplify it. It will give me 2 over 5, dividing by 3, dividing by 3, which is terminating semester. I will take it. 7 over 15, no, I missed it. It will not simplify to anything. 8 over 15, no. 9 over 15, yes. Simplifying, divided by 3, dividing by 3, I missed it will be 3 over 5, which is terminating. So I'm going to take it. What else is there, Mr.? 10 over 15. Yes, 10 over 15. Dividing it by 5, dividing by 5 is going to give me 2 over 3. Ah, no, I missed it. That's recurring. I'm not going to take it. What else is there, Mister? 11 over 15? No. 12 over 15? Yes, it will simplify. But to what? 12 over 15? Dividing it by 3, Mister, is going to become 4. Dividing by 3 is going to become 5. Okay, this is a terminating decimal. So I'm going to take it. 13 over 15? No, 14 over 15 will not simplify. That's the Mister. They said it's less than 15. So how many possible answers are there? The possible values of n are actually here. If n is 3, so I got here 1, 2, 3, 4 possible values of n. So it is a 4. 33. Work out 8 over 9 plus 1 and 1 over 3 divided by 4 and 4 over 5. What are we supposed to do here? I do this. 8 over 9, I'm going to keep it the same. Plus 1 and 1 over 3, I'm going to turn it into an improper fraction. And Mr. 3 times 1 is 3, plus 1 is going to become 4 over 3. Divided by, turn this into an improper fraction, so it is going to become 24 over 5 equals 8 over 9 stays the same, plus 4 over 3 stays the same. Keep, change, flip. I have to finish the division first, Mr. Order of operations. So multiply by 5 over 24. Simplify, then multiply. I must finish this first. You cannot add first. Dividing here by 4 is 1. Dividing here by 4 is 6. That's it, mister. Oh, mister, can I simplify the 6 with the 8? Excuse me. We said this cross multiplication thingy works only in multiplication. It doesn't work with addition or subtraction. So 8 over 9 stays the same. Plus 5 over 18. We need to make the denominators the same. So multiply by 2 becomes 16 over 18 plus 5 over 18 equals 21 over 18. Simplify becomes what? Divided by 3 gives you 7 over 6. Turning this into a mixed number, read the question well. 7 over 6 becomes 1 and 1 over 6. How did you do it, mister? How many 6s are in 7? 1 6, remainder 1. with the denominator does not change. 4 marks, you see? You need to be careful. Those who will start right away with adding first, unfortunately, you're gonna lose 4 whole marks. That would be a problem, a very big problem. Here, is it true or false? So the student one's work is 7 divided by 1 over. Definitely, you need to read the whole question. Do not do like Mr. Ahmed. I know what the question wants first. I know what the question wants, so I just went right away to the answer. So student one's work is 7 divided by 1 over 8. So he said, I'm going to keep 7 stay the same. Then I will change multiplication. 1 over 8 becomes 8 over 1, which is just 8. Is this correct or not? True, Emister. Thank you. Here, 15 divided by 3 over 4. He flipped the 15 and flipped the 3 over 4. No way, Emister. False. Here, he said I'm going to do 27 multiplied by 2, then plus 27 multiplied by 5 over 8. Is this correct, Emister? Yes, definitely true. You can do this. Yes, I can do this. Multiply the 27 by 2 plus multiply 27 by 5 over 8. You finish this, then you add it to this. Here, Mister, can I do the same thing? I do the 6 multiplied by 3. Yes. Then times is 6 multiplied by 5 over 7. Can I multiply the 6 by 5 over 7? Yes, you can multiply 6 by 3 first. And you multiply 6 by 5 over 7 next. But at the end, you must add them, not multiply them. So it is false. I can do 6 times 3 plus 6 times 5 over 7. So it is false. Come on, erase this. Go down. Work out, and they want you to give your answer as a fraction in its simplest form. So, mister, I'm going to start with the division. So 1 minus 7 over 10, keep, multiplication, change, 1 over 7, flip. So 1 minus 7 over, mister, I need to simplify first. Simplify them, multiply. Divided by 7 is 1, divided by 7 is 1. So 1 over 10. What is 1 minus 1 over 10? The rest of the fraction, mister, until I reach 10 over 10, which is 9 over 10. Or in other words, as if I'm saying a 10 out of 10 minus 1 over 10 is 9 over 10. Why do I always do this? Okay. Convert into an improper fraction. 5 times 1 is 5, plus 3 is 8 over 5. Times 8 times 4 is 32, and 1 is 33 over 8. Bye-bye, bye-bye. Divided by 8 is 1, divided by 8 is 1. Here is 33 over 5. Converted into a mixed number. The denominator stays as it is. How many 5s are in 33? 6, remainder 3. Jamila writes these rules about fractions and their decimal equivalents. Tick to show if each of Jamila's rules is true or false. Fractions with an even denominator will always be equivalent to a terminating decimal. No, mister, that's not true, because if I say to you 5 over 12, for example, sorry, why am I saying 12 and writing 16? 5 over 12, for example, the denominator has a prime factor other than 2 and 5. It will be recurring, mister, and even 1 over 6, mister. You see that? 1 over 6, mister, is also recurring. So no, always will be equivalent to a terminating decimal. False. Fractions with a denominator which is a multiple of 9 will always be equivalent to a recurring decimal. Always, mister? Well, what do you guys think about this? No, mister, because they can have 18. Look at this. That's a multiple of 9, right? A denominator which is a multiple of 9. Yes, mister. And I can have here a 9, which is actually a half, which is actually a terminating decimal, right? So it is false, mister. Not always. In most cases, yes. Like if I say to you 7 over 18, if I say to you even many other numbers over 18, it will be recurring, yes, in most cases, but not always, because I can simply say 9 over 18. All right, work out this. Mr. D decimals, what brought this to fractions? Well, let me tell you something. You can make it into a decimal, multiplying 8 by 75, then you put the point after two decimal places, and then you square the answer. That's going to be hectic. That's gonna be actually, it's worth only 1 mark. I need to think about this in a smarter way, a much smarter way. It is 8 multiplied by 3/4. 0.75 is actually 3/4 squared times half. You can make the half into a fraction as well. It's up to you. So here, Mr. Well, let's make it a Mr. into a fraction. I don't mind. So here, 8 times 3/4, simplify, then multiply. Divided by 4 is 1, divided by 4 is 2. 2 times 3 is what? 6. 6 is squared is 36. So what is the half of 36? Or 36 times half, or 36 divided by 2 is 18. See, so much simpler than multiplying decimals, and then you multiply the answer that you will get by itself. It's paper one. That's going to be really a really big problem. You're going to waste the time of many other questions. Think smart and work smart, not hard. All right, 2 over 5 multiplied by 127. I need to do what? I need to do a method over here. The multiplication because I cannot simplify actually. So 2 multiplied by 127 is going to give me exactly 254 over 5. I hope I didn't make a mistake in multiplication. But yes, it's going to be 254 minus 14, yeah, mister, over 5. I have to finish the multiplication first here, the multiplication there. Then, yeah, mister, I'm going to subtract. So this is going to become 240 over 5. Mister, if I leave it 240 over 5, would it be a mistake? No, they did not request from you the simplest form. So 240 over 5 is correct. But please, Mr. Ahmed always requests from us. Here it is division. La, you must work it. You must finish it because actually it's going to give you a whole number, not a fraction. So I must finish this. Please don't leave it this way. I'm sorry. I said to you, you can leave it this way. No, you can't. You need to finish the division. 240 divided by 5. 5 goes into 2, 0. But it goes into 24 4 times, and Mr. remain the 4. So 5 goes into 48 times, and Mr. So it is 48. 240 divided by 5 is 48. Let's continue. I'm going to convert this semester into a mixed number, into an improper fraction. So it becomes 8 over 3. Multiply by 5 times 1 is 5, plus 5 plus 1 is 6 over 5. But the reciprocal emissor, flip it, it is 5 over 6. Divide by 2, 4. Divide by 2, 3. 4 times 5 is 20, 20 over 9. Convert this into a mixed number. So the denominator is 9, as it is. How many 9s are in 20? I have 2 9s and remainder 2. So 2 and 2 over 9. 1 minus 3/5 is 2/5 semester. 1 whole, take away from it 3/5. What is left? 2/5. Divided by 1 whole, take away from it 5/9. What is going to be left? 4/9. Or as if you're saying 5 over 5 minus 3 over 5, 2 over 5. 9 over 9 minus 5 over 9, 4 over 9 equals, keep change flip. 18 over 20. Simplest form. Mister, I forgot to do the simplest form before. I could have done divided by 2 is 1, divided by 2 is 2. Then it is going to become 9 over 10, yeah, mister. 9 over 10. I forgot. Can I simplify afterwards? Yes, not a problem at all. Dividing it by 2 is 9. Dividing it by 2 is 10. The same thing exactly. But it's easier to simplify before multiplying in most of the cases, since multiplication will lead to much bigger numbers. Carlos says all fractions with an odd denominator are equivalent to recurring decimals. For example, 1 over 3 equals 0.3 with dot notation above the 3, which means it or shows that it's recurring. Find an example to show that Carlos is wrong. Mister, I can simply say to you that an odd denominator is 9, like what we've done. Not a 9. Let's say here 5. That's an odd denominator, right? He requested it, an odd denominator. That anything a Mr. over 5 is going to be terminating. 1 over 5 is terminating. 2 over 5 is terminating. 3 over 5 is terminating. 4 over 5 is terminating. All of these semester are terminating decimals, will turn into terminating decimals. Work out this. I have to convert them first semester into improper fractions. 5 times 4 is 20 and 2 is 22 over 5 minus 3 times 2 is 6 and 2 is 8 over 3 minus plus 1 over 3. Order of operations, Mr. Ho, I have only addition subtraction. Yes, but remember that we say addition or subtraction in order from left to right. Whatever comes first is done first. So I must do this first. 22 over 5. I'm going to do what? I'm going to do it minus. So multiply this by 3, multiply this by 3, multiply this by 5, multiply this by 5. Can I, Mr. also multiply this by 5? Yes, fine. Multiply this by 5, multiply this also by 5. So all of them will be what? All of them, Mr. will be over 15. So multiplying this by 3 is 66 over 15 minus this is going to become 40 over 15 plus this will become 5 over 15 equals 66 over 15 minus 40 over 15 will give me a Mr. 22 over 15 plus 5 over 15 equals a Mr. 27 over 15. Write it as a mixed number in the simplest form. It's going to Mr. Simplest form first, dividing by 3. Dividing by 3 equals 9 over 5. As a mixed number, Mr., it is going to become 5, the same. How many 5s are in 9? I have 1 and 4 over 5. Let's continue. 1 and 5 over 6, Mr. remains, I'm going to make it into an improper fraction. So it is going to become 11 over 6 plus 3 times 2 is 6. 6 plus 2 is 8 over 3 times 3 over 16 equals 11 over 6 stays the same because I must finish first the multiplication, Mr. Plus, here, can I simplify first? Yes, definitely, that's multiplication. We can simplify first. Dividing by 8 is 1. Dividing by 8 is 2. Dividing by 3 is 1. Dividing by 3 is 1. Yeah, but 1 times 1, Mr. is 1. Over 1 times 2 is just 2. Now, I'm going to multiply this by 3 and this by 3 to make the denominators the same. 11 over 6 plus 3 over 6, which is 14 over 6. Dividing it by 2 will give me what? 7 over 3. That's the simplest, sorry, by 2. That's the simplest form. Mister, do you want it as a mixed number? Or even if they don't want it, please always write it as a mixed number. This is 3. How many 3's are in 7? I have 2 3's, remainder 1. So 2 and 1/3. Write a number in each box to complete the calculation. 3.5 Mister is what as a fraction? Well, 3.5 Mister is what divided by 2? The half of what? In other words, the half of what is 3.5? The half of 7 Mister. Half of 7 is 3.5. So 7 over 2. Now, here the division, they changed it into multiplication. So 7 over 8, flip, keep change, flip. 7 over 8 becomes 8 over 7. Simplify, then multiply. Divided by 7 is 1, divided by 7 is 1. Divided by 2 is 1, divided by 2 is 4. So 1 times 4 is 4 over 1, which is just 4. This is the last question. No, not the last. I was hoping. All right. So calculate here. Convert into an improper fraction becomes 13 over 4 minus 2 times 1 is 2 plus 1 is 3 over 2 plus 3 times 1 is 3 plus 1 is 4 over 3 equals 13 over 4 minus 3 over 2 plus 4 over 3. I need to make the denominators of the same, mister. Okay, let's do it. Here is going to become times 3 up times 3 down. We hear times 2 up times 2 down. What is it going to be? It is going to become, mister, here 9 over 6 plus 8 over 6 equals here 13 over 4 minus 17 over 6. Mister, can I now, in order to subtract this, I must make the denominators the same. So I'm going to multiply this by 2 and this by 2. I'll multiply this by 3 and this by 3 to make the denominators 12 and 12. 17 times 2 is 34. 3 times 13 is 39. So it is going to become 5 over 12, yeah, mister. And it is already in the simplest form. Mister, how come they want something that is in the middle between this and that? There is nothing in between 6 over 13 and 5 over 13. Forget about the negative sign, mister. It's not confusing me actually because I know that this is going to become negative anyway. And they're even putting the signs for me there. So the sign should not confuse me. But what I'm confused about is that how on earth is it possible that I find something in between 6 over 13 and 5 over 13? Is it possible, Mr., that I write 5.5 over 13? No, it is not possible that you do this. I need an integer in the top, an integer in the bottom. But Mister, how is this even possible? So it is actually possible because you're supposed to make an equivalent fraction to this. Multiplying it by 2 up, for example, and 2 down. It is going to be equal to what? 12 over 26. Definitely negative. Yes, we agreed we're going to ignore plus the sign. It's never going to confuse us. Shouldn't confuse us. So this is going to become 12 over 26. I'm going to do the same thing exactly over there. It is equal to 10 over 26. So what is in between now? Mister, I found the two equivalent fractions for both of them. So there is something in between now. It is 11 over 26. Negative 11 over 26 is going to be there. Okay? If I wanted more numbers in between, you could have multiplied this by 3 and this by 3. That will create a bigger gap in between. You could multiply this by 10 and this by 10. That will create an even bigger gap between the two fractions. And we're still talking about equivalent fractions. Next, work out 2 and 1 over 5 minus 14 over 15 times 3 over 8. What are we supposed to do here? I'm supposed to, Mr. to finish first with the multiplication. So I'm going to keep this as it is, 2 over 2 and 1 over 5. But let's make it a Mr. Khalas into an improper fraction. One step. It's going to become 11 over 5 minus. Can I simplify first? Yes, definitely. You must simplify first before multiplying, as we agreed. Dividing by 3 is 1. Dividing by 3 is 5. Dividing by 2 is 4. Dividing by 2 is 7. So it is going to become 7 over 20. Good? Now I need to make the denominators the same. Multiplying it by 4, multiplying it by 4. We'll turn this into a 44 over 20 minus 7 over 20 equals, you're going to find that it is 37 over 20. Mister, is this the final answer? No, because they want a mixed number. So what am I supposed to do? How many 20s are in 37? Yeah, Mister, it's only 120 in 37. The 20 stays the same. But what is the remainder? There is only 120 in 37. Yes, I agree with you. But what is going to be the remainder? I have remainder 17. That's it. Thank you so much, everyone. No, I still have here another fraction. I thought that was the last page. Okay, not thank you, everyone. Not yet. All right. I'm just curious to see how many pages are the last page. Inshallah, this is the last page. Khalas. Okay. So here it says to you in 47, 1 over n is equivalent to a recurring decimal. N is a whole number. Safia says n must be greater than 5 for it to be a recurring decimal. Write a number to complete this sentence. Safia is not correct because the value of n could be 3, right? 1 over n to make it recurring, and it can be less than 5. Well, mister, I can make it 1 over 3, right? And it is going to be a recurring. That's why she is not correct. So the answer here, don't say 1 over 3. They want the n. The n could be 3. So let me erase this. Next, 1 over 9 is 0.1 and a dot notation above the 1. Use this fact to convert a 7 over 9 to a decimal. Don't go over there and do the division, please. For God's sake, don't do this. They want 7/9. They gave you 1/9. They want 7/9. So it is the same as 0.1 dot notation above the 1 times 7, which is 0.7 dot notation above the 7. In other words, as if you're saying to me 0.11111 times 7 equals 0.7777, and so on, which is a mister just 0.7, a dot notation above the 7. Now I can say confidently, thank you so much, everyone, and see you in another video.